this is the Earth. You're standing on the middle of the planet here with your phone, and then there's like multiple satellites out here. We'll put 4 satellites out here. It takes a minimum of 4 satellites to get a GPS signal. These are not to scale. So when you're standing here and you think your cell phone is sending you a location, what's happening is these satellites all have a known location and a time. They have really precise time on them. So what they do is they send a signal down to you, and in this signal it tells you the location of that satellite and what time it was there. So when you receive this message, it receives the message of the location of the satellite and what time it was sent and what time it was received. So it uses calculates the speed of light to figure out the distance between both of these. So then the next satellite sends you a signal to your phone, and the next one sends you a signal to your phone, and you get all 4 of them that go in there. And what they do is they sit there and they calculate with the speed of light how long it took for each one to travel, and they have very precise, the whole thing is based off of having precise time. So then once it figures out this distance, and it calculates a distance into you. So you get 4 accurate distances in, and then that's your mapping grade location. So this location is like within 10 feet. So you'll be like that big. And then what happens is, and that's fine for your phone. That's about as accurate as you're going to be able to get it for your phone. But then you, if you want to get to survey grade, all of a sudden you have atmosphere around the outside of the Earth. And this atmosphere is slowing down the signal that's going to be coming in at the speed of light, and then it goes through the atmosphere, so it slows it down. And that's what throws off the signal. That's why you're within 10 feet. If we didn't have atmosphere, then it would be very accurate. So what happens is we get a secondary, for survey grade, we get a secondary GPS set up on a known location. It's set up over a known point, and then that calculates out to that point. And at that point, it can tell you that it can calculate what this air is going through the satellite, going through the atmosphere. So it calculates all that, and then it can adjust to the actual map location, and then it sends a radio signal to your phone and says these signals you're receiving are off by a certain distance. So then what happens is then you're down to a very precise location of like a centimeter. For your phone, the best you're going to get is 10 feet. But with our survey grade, you can get it down to a 1/4 of an inch. And then a couple weeks ago, we had this other problem. We had the sun was up here, and the sun started sending out solar flares. So the solar flares started going through all these signals and threw everything off. So that's how the whole Earth and stuff happen. You know, you think you're going to get a accurate location on your GPS on your phone all the time, but there's so many other factors going on at the time for calculating it that it isn't too far off to try figuring out why it's wrong and what's happening.